In this video, we want to solve this equation, find x, and we want to see how changing variable is useful working with powers. So please don't forget to subscribe my YouTube channel and turn on notifications. So let's solve this problem. Also, you can use the card on top of my video to see other Harvard, Stanford, Olympiad problems. So let's see. 8 to the power of x. 8 is what? 8 is 2 cubed to the power of x plus 27 is what? 3 cubed to the power of x equals 2 times. If we prime factorize 18, it will be what? It will be 9 times 2 and it will be 3 squared times 2. So I write 3 squared times 2 to the power of x. Now I want to simplify. I say, okay, it's what? 2 to the power of 3x. When you have this, you should multiply. Plus 3 to the power of 3x plus 2 times. When you have product to the power of x, you say this to the power of x times this to the power of x. So it will be 3 to the power of 2x times 2 to the power of x. Now we want to see what we see in both sides. We want to divide. So here we have 3 to the power of 2x, 2 to the power of x, and these things. Now here I want to get, for example, rid of this term if I divide both sides. So I want to divide both sides by 3 to the power of 3x. So it will be what? 2 to the power of 3x over 3 to the power of 3x plus 3 to the power of 3x over 3 to the power of 3x is 1. And we know it is not 0 when we want to divide something. 3 to the power of something is not 0. 2 times 3 to the power of 2x times 2 to the power of 2x over 3 to the power of 3x. Now, if we simplify, we will see what? It will be 2 to the power of 3x, 3 to the power of 3x. We can say what? We can say it is 2 cubed over 3 cubed to the power of x. Because if we have this, 2 to the power of 3x and this, we can consider this x for both of them and write division like this. Plus 3 to the power of 2x here, 3 to the power of 3x. Then, because it is division, you subtract 3x minus 2x, x. It will be 2 times 2 to the power of x, 3 to the power of 3x minus 2x, which is x. Now it's good. Why? Because we can write what here? It is 2 to the power of 3. Let me tell you, I want to consider 2 over 3 equals a. So then I can say what? Then I can say 2 cubed over 3 cubed is a cubed. Now, here I can say it is equal to 2 times 2 over 3 to the power of x. Now, here you can say 2 cubed over 3 cubed is what? A cubed. So, here, because we want to get rid of x, it's better to do what? So, look, sometimes you consider changing variable and you check. And after checking, it's so much useful. Don't be afraid of, for example, writing something, right? And after that, you can correct it. So here I consider it is a to the power of x. So it is a to the power of 3x. Now, here if you pay attention, it will be what? If a to the, let me show you this one, correct this part. 2 over 3 to the power of x. If I consider this one, then I understand what? Let's check it. So it will be what? A cubed. You can say it is 2 over 3 to the power of 3x. Okay, so now that's good. So here we can use that. It is this part. You can also write it as 2 cubed over 3 cubed to the power of, let me write it better. Okay, it is what? It is a cubed. So here I can write it is a cubed plus 1 equals 2 times this, 2 over 3 to the power of x, 2a. So we have a cubic function. Take all things to left hand side. It will be what? A cubed minus 2a plus 1 equals 0. It is cubic function. One of the most useful idea when you have cubic function is to check small integers, which of them is 0. So if we check a1, you will see 1 cubed minus 2 times 1 plus 1 is 0. Because 1 works, so one factor is a minus 1. For example, if a equals 2 works, then a minus 2 is a factor. Now we should find the second term. So because we have a cubed, you place a squared. A squared times a is a cubed. Then minus a squared, so we should place plus a squared minus a squared. It will be 0 for a squared because we don't have a squared. Minus a, we should reach negative 2a. So if you place negative 1 here, negative a, and negative 1 times negative 1 plus 1 equals 0. So because product of two term is equal to 0, we can say what? A minus 1 is equal to 0, or a squared plus a minus 1 is equal to 0. For the first term, a minus 1 equals 0, so a equals 1. And if you want to check these things, a equals 2 over 3 to the power of x. So if I write a equals 2 over 3 to the power of x. So from these two things, we conclude 2 over 3 to the power of x equals 1. Now, if I want to draw 2 over 3 to the power of x, it will be this diagram. And for it goes to 0 for large x, and for large negative x, it will be positive infinity. So the only case that it is equal to 1 is when x equals 0. So we found one answer. Now, let's consider the second case. A squared plus a minus 1 equals 0. Now, here you should use what? Here you should use quadratic function. If you have ax squared plus bx plus c equals 0, then x will be negative b plus minus b squared minus 4ac over 2a. Now here, if we use that, a is negative, b here is 1, negative 1 plus minus root 1 minus 4ac, which is minus 4 times negative 1 all over 2, and it will be negative 1 plus minus 1 plus 4, which is 5 over 2. Now here we say what? We say, okay, a, because as you can see also in the diagram, it should be greater than 0. And if you consider negative, it will be less than 0 and contradiction. So we understand here we should only consider positive sign. So a is this. Now, we know a was what? 2 over 3 to the power of x. So when you have something like this, let me tell you, for example, when you have a to the power of x equals b, it is equivalent. If you take a log from both sides, it will be this. And the definition of this log b in base a, we say it is a number that if you raise a to the power of that, you will reach b. So this number x is a number that if you raise a to the power of that x, it will be b. So as you can see here, it is 2 over 3 to the power of x equals negative 1 plus root 5 over 2. And by the definition of log, x equals log what? B here is negative 1 plus root 5 over 2. In what base? In base a here, 2 over 3. So we should calculate this number. If you want to calculate this number, it is not important to consider in what base. We have an important rule in logs. It is what? It says log A, it's one of the most important rules in log. And log A in base B, log B C, here it will be log. You can cancel these to B, it will be log AC. And now here you can conclude what? If you consider log A B times, here, let me tell you. For example, by this one, let me tell you also one important rule. Sometimes you can write also this log, you can cancel this to A, log BB, which is 1. There are around 15 important rules in logarithms that if you know them, you can solve any problems. If you have any question about logarithm or other things, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay, so now here, when you see something like this, log A, B, you can write log A over log B, and only the base should be same. Why you can write this? For example, you can consider this 1010 or any other number. Why? Because it is equivalent that if you multiply these two things, it will be log AB log BC equals log AC. So if you see, it is exactly this rule that I said. BB will be cancelled log AC. So here, if you want to use calculator, you can say it is a log -1 plus 5 over 2 over log 2 over 3. So if you use you can write it like this, or if you want, you can use calculator. It will be around 1.1868. So one answer is this, x equals this, and the other answer, x equals 0. So we found two answers for this. Also, you can use my other videos, and please don't forget to subscribe my YouTube channel and turn on notification. Okay, bye.